Let's look at organic oxidation and reduction reactions. In general chemistry, we looked at oxidation-reduction reactions as the gain or loss of electrons. In organic oxidation-reduction reactions, forget about those electrons, look at the gain or loss of oxygen or hydrogen. For example, methanol is oxidized to formaldehyde. Note that methanol has one oxygen and three hydrogens bonded to that carbon. Formaldehyde has two oxygens and two hydrogens bonded to that carbon. Treat a carbon-oxygen double bond as two carbon-oxygen single bonds. Alcohols can be oxidized to aldehydes, acids, or ketones, and it depends on the type of alcohol. So, for example, primary alcohols are oxidized to aldehydes or acids, depending on the oxidizing agent. Secondary alcohols are oxidized to ketones. Tertiary alcohols, no reaction occurs. Here are some common oxidizing agents: hydrogen peroxide, bleach, potassium permanganate, sodium dichromate, and PCC. PCC is a weak oxidizing agent. For common reducing agents, hydrogen, sodium borohydride, and lithium aluminum hydride. Let's look at a few examples. First, is ethanol a primary, secondary, or tertiary alcohol? Stop the video and think about that for a second. Ethanol is a primary alcohol. So note that when ethanol is oxidized using the weak oxidizing agent PCC, it forms an aldehyde. The aldehyde is further oxidized using the stronger oxidizing agent, sodium dichromate, to form acetic acid. If the ethanol is treated directly with the strong oxidizing agent, sodium dichromate, it goes directly to acetic acid. And if you look at the reverse reaction, the acid is reduced to the alcohol. As college students, you may have had a drink of alcohol. So answer these questions. Is alcohol being oxidized or reduced? And ADH is an enzyme which converts the alcohol to the aldehyde. ALDH converts the aldehyde to the acid. So when this enzyme runs out, what do you think happens? So stop the video and think about that for a second. Answer: ethanol is oxidized. When ALDH runs out, you get a hangover. Let's practice. Identify each reaction as an oxidation or reduction, and identify the reagent you would use. For the first reaction, note that that carbon has one oxygen and one hydrogen. The product has two oxygens, zero hydrogens, so that means this is an oxidation. The second reaction is the reverse of the first reaction, so this is a reduction reaction. And this reaction does not occur because this is a tertiary alcohol. Oxidation reduction is very common in biology, so biological oxidizing agents include NAD plus and FAD. Reducing agents include NADH and FADH2, depending on the bond. So in glycolysis, step 6 is that reaction, oxidation or reduction. So stop the video and think about that for a second. Note that the alcohol is converted to a ketone, so that must be an oxidation reaction. You may have done tests for reducing sugars in a biology class. So the tolerance test and Benedict's test are two common tests. Is the reducing sugar oxidized or reduced? So think about that for a second. In the first reaction, note that we have an aldehyde converted to an acid, so this is an oxidation reaction. In the second reaction, again, we have an aldehyde converted to an acid. That's also an oxidation. It's called a reducing sugar because the sugar is reducing either silver plus to silver, or it's reducing copper 2 plus to copper 1. Lipitor is a cholesterol lowering drug. Note in the synthesis of Lipitor, This group is converted to that group, so that kind of reaction is a... Stop the video and think about that for a second. It's a reduction reaction. Other functional groups can be oxidized or reduced. Note that an alkene can be reduced to an alkane. Note that each carbon is gaining H's. Note that a nitrile can be converted to an amine. So is this an oxidation reduction? Think about that for a minute. This carbon has no H's. This carbon has two H's. This N has no H's. This N has two H's, so it must be a reduction reaction. You can use a common reducing agent, sodium borohydrate or lithium aluminum hydride, for this reaction.